Hello friends, welcome to my channel. This is Isro question paper strength of material from 2006 to 2016 fully solved. A beam is having a triangular cross section with its neutral axis xx. The section modulus about xx is given by how much? Section modulus. It's first moment of inertia, it's bhq by 36 along neutral axis. Then section modulus is ixx by y maximum from this distance to this distance 2 by 3 h. So bhq by 36 divided by 2 by 3 h. So zxx equal to bhq by into 3 by 2h. 3 12 h square. So it will come bh square by 24 z axis. Bh square by 24. C is the answer. A column of length L is fixed at bottom end and hinged at the other end. This column is restrained from lateral displacement at 1/3 height. The buckling load is given by this buckling type questions already discussed so many times. So Euler's critical load pi square EI by effective length square. So our effective length is this one. Effective length. Put the value by 2L by 3 square. So 9 by 4 pi square EI by L square. From option 9 pi square EI by 4L square. A is the answer. This question was also already discussed so many times. A rectangular column is subjected to an eccentric load P at a distance E from centroidal axis. The stress diagram at cross section will be how much? So, rectangular column subjected to an eccentric load P, middle is E. So how it will come? The eccentric load, it can be converted as one compressive load P and one moment P into E. So this side tension, this side compression. So here bending stress plus already minus axial stress, compressive, so it's minus. This side both are negative, sigma B minus axial compressive stress. So negative part is more and positive part is less. This one negative part, this one positive part. So from option it is not possible. B both are same, positive negative, so not possible. Here positive part is more. This is also not possible. So D is the answer. Next, the figure below shows a steel rod of 25 mm square cross sectional area. It is loaded at 4 points KLMN. Assume E steel equal to 200 GP. The total change in length of rod due to loading is how much? This type of question so many times asked in IAS. Get also this type of question asked in IAS 2016. Also this type of question was asked. So here the formula is load P, L length, area of crossing is Young's modulus. So excuse me. If we put the total load, total elongation del L equal to 1 by AE into P1 L1 P2 L2 plus P3 L3. Put the individual values. 25 into 200 into 10 to the power 3. Here 100 into 500 plus this is compression minus 2 into 800 plus 50 into 400. So 1 by 5 into 200 50 minus 58 plus 20. 25 into 200 to minus 50 minus 1 by 100 mm. So in micron it's 10 micron. Draw that. Newton here 50 Newton. If you take individually, how you got P1 P2? From here we will get P1 P2. First figure 100 Newton P1 100 Newton. Second one compressive, how much? From here if you take left side, compressive 250 and tensile 100. So it is minus 150 or 150. This is kilonewton. Kilonewton, 150 kilonewton, both are compressive. For third figure, if you take right side or left side, (200 minus 150), it's 50 kilonewton. From here you will get P1, P2 and P3. L1, L2 from that figure itself you will get. This is 500 mm, 800 mm, 400 mm. So if you put the values in this formula, you will get the answer. minus 10 micron. So from option it's B, minus 10 micron. Next question. The Mohr circle reduces to point when the body is subjected to dash. I think this is fourth time or third time I am solving the same question. Point. Mohr circle reduces to a point. D is the answer. Already discussed in my previous video. This is a very weak question. If you solve this one, it will take around 3 to 4 minutes. So better you leave this question. What I am solving here, the question is, in GATE examination this type of question they are asking. So I am solving this question. In IAS also, in conventional paper they may ask this type of question. A concentrated load P is applied at the end of a cantilever as shown in figure. The cross section of the beam is a square of side A with a hole of diameter A by 2. The deflection at the tip of the cantilever is given by how much? Figure given. Deflection they asked. At the end, deflection we know delta is PLQ by 3 EI. This is very important for cantilever. I is for base. For one side it's BHQ by 12 for square cross section. It's, you take two triangles. This one and this one, multiply with 2. So along base, triangle moment of inertia is same as rectangular cross section. This is rectangle. BHQ by 12. Base equal to square plus a square root over. How much it will come? Root 2a. And your h equal to this height, which is h. H equal to a by 2. A by root 2. So for total A, 2 into base, moment of inertia along base, BHQ by 12. So root 2A, A by root 2, Q into 2 by 12. So it will come root 2, 2 cancel. So it will come 2 1 root 2 and 2 root 2 square cancel. It's A4 by 12. Then for circle, moment of inertia is pi by 64 d to the power 4. So D is A by 2. Pi by 64 into A by 2 to the power 4. How much you will get? Pi by 64 into A4 by 2 to the power 4 is 16. So from triangle you multiply that one, two triangles, minus circle moment of energy, 2 into triangles, or that square cross section, moment of inertia of the square, minus moment of inertia of circle. Already we got A4 by minus pi into 4 into 64 into 16. How much it will come? A4 you take common, A4 by 4, it will come 1 by 3 minus 4 into 64. So that cross section moment of inertia, it will come 4 into 256 minus 3 pi by 4 into 3 into 64. Then here delta PLQ by 3 EI. We put PLQ by 3 into E. I value we already got. A4 by 4, 256. This is a very time taking question for IES and GATE. It is very important. For Isro you leave this question. 4 into 4 into 64 into P LQ divided by E into A4 into 256 minus 3 pi. So how much you will get if you solve this one by using calculator? For P 256 minus 3 pi E into LQ by A4. From option delta equal to √2 for P by 256 minus 3 pi E LQ by A4. This is the answer. From option, here options I missed. From option you will check and you will get the same answer. Next, a cantilever beam is subjected to a UDL. The cross section of the beam is AH section placed as shown in figure. The bending stress distribution across the cross section will be how much? Section is H section. So bending stress It will come like this. In option you check this figure and you will get your answer. A thick cylinder of inner dia D, capital D, wall thickness T2 and length L is sealed at its bottom ends with caps. The thickness of the cap is T1. Allowable tensile yield stress sigma y and allowable shear stress tau y. A gas is pumped into this cylinder at pressure P. The cap will yield in shear at circumference of diameter D when the gas pressure applied is more than this. A, B, C, D options are given. So, sealed at both ends. The cap will yield in shear. So, at end cap, here, at end cap, the pressure will act. So, for pressure into resisting area, yield stress into pi d shear area. Pi d thickness was given as T1. So if you solve this one, pressure force equal to shear force. This is pressure, this is resisting area. Here this is yield shear stress and this is shear area. Solve this one. Pi cancel, d square d will get 4 T1 tau y by d. This one you will get from option 4 T1 tau y by d. A is the answer. Thank you friends for watching my video. If you like my video, then subscribe it and don't forget to share with your friends. Thank you.